Hi there. My name is TJ Laher, Director of Product Marketing at Confluent, and I'm really excited today to talk to you about how we are connecting distributed data to Cosmos DB with Apache Kafka and Confluent. I'm joined today by Jake, who's on our Confluent team. Jake, you want to introduce yourself real quick?
Yeah, thank you, TJ. Hey, everybody. My name's Jacob Bogie, and I'm a Cloud Partner Solution Architect here at Confluent, and I look after our partnership with Microsoft, and happy to be here to talk about what we're doing with Cosmos DB and Apache Kafka.
Awesome. So let's dive right into it. So we're just at the context a little bit. I don't think it's a shocker to anybody on this call that data is changing the world. It's changing the world in two different perspectives from our vantage point. One, the customer experience has significantly changed in terms of the expectations that consumers now have when they interact with your product, company, or service, especially across omni-channel experiences, digital and physical worlds. So how can we take those real-time customer events and actually put those into action to offer a better, more richer, fuller customer experience, and at the same time power richer real-time backend operations as well? Because while our employees are employees, they're also consumers in this world, and they're experiencing this new transformation that they touch every day in terms of ordering an Uber on their phone, and they want to have that same real-time experience for their backend operations in terms of predictive maintenance, fraud detection, real-time telemetry data coming off of their product that they're monitoring. So being able to power these real-time front-end experiences and back-end operations to move your organization forward is extremely critical. And what we're seeing is a lot of organizations trying to move from their on-prem environments over to Azure to build these rich experiences and power these new real-time experiences as well. And for good reasons. Cloud offers a wide variety of advantages in comparison to the on-prem environment, whether it be agility, elasticity, cost savings, or just faster time to deployment. So as people are thinking about how to build these modern data platforms, especially with Cosmos DB on Azure, there's a lot of benefits that they're seeing with these migration and modernization initiatives. And one thing that we've seen as people rethink their cloud-based data platforms is how do they fit data streaming into this equation so that they're not so much thinking about a batch-based paradigm anymore of I'm getting this data to my end system or my employees or my customers on a hourly basis or a daily basis, but how can I actually get this insight and this information to the right folks at the right time, using real-time data streaming capabilities as part of their modern cloud data platform. And this data streaming technology that Confluent offers is built on top of an open source project called Apache Kafka that I'm sure a lot of you are familiar with. It's one of the fastest growing open source projects in the world. Our founders of Confluent actually built this project back at LinkedIn. And since then, we've had a wide adoption across a wide variety of industries. And last time we checked, around 70% of Fortune 100 companies actually use Apache Kafka to power these real-time experiences. And at Confluent, what we've done is we've re-architected Apache Kafka to remove a lot of the complexities and make it a cloud-native service so that you can build faster on Azure, you can connect and migrate more data sources in real time to Azure services like Cosmos DB, and you can have it be fully integrated with those core Azure services that you know and love. So you can have a unified security management and billing console all connected directly through Confluent Cloud. So with that, I want to pass it over to Jake to double click on our integrations with Azure. Jake.
Thank you, TJ. So we've got a great partnership with Microsoft. We actually have a strategic partnership, which we've just recently announced. And what that's going to do is that's going to drive better innovation and better integration between the Confluent platform, the Confluent Cloud, and Microsoft Azure. So what you'll see is we've already got integrations directly with a lot of the Microsoft native services that you might be using. And to power that data in motion platform, we'd like to be able to show you some of those services. Most specifically today, we'll talk about Cosmos DB and connecting it to Confluent Cloud. But if you think about it, that data platform that you're building has access to Azure Synapse, Azure Data Lake, Azure Blob Store, and you'll even see the use of Azure Functions a lot with Confluent Cloud as well. We've got deep integration with some other ISV third parties like Snowflake and Databricks and Elastic. And what's really amazing is you can actually purchase and transact the Confluent Cloud directly through the Azure Marketplace. So if you've got an existing MAC agreement and you'd like to burn some of that MAC agreement down, you can do so directly through the Marketplace. And Confluent Cloud is a preferred solution on Azure. So it's been vetted, the security's been proven, and it's very, very impactful for organizations that are looking to build those data in motion platforms specifically on Azure. So if we think about it, Confluent Cloud, we like to describe it as being cloud native, complete, and everywhere. So when I say cloud native, it really is Apache Kafka that's been built and enhanced to run specifically on Microsoft Azure and deliver the performance that you would need from an event streaming platform in the cloud. But we also give it the ability to be a true complete system where you can build real-time apps using Azure integrated services, have it be able to handle whatever platform needs you've got for data in motion, and it's everywhere. So I like to be able to explain to folks that, hey, you can actually still maintain an on-premise Kafka environment or an on-premise Confluent environment and integrate it directly with an environment in Azure or one of our offerings through Confluent Cloud that's running on Azure as well. So cloud native, complete, and everywhere. Think about that when you're trying to deliver an event platform or a data streaming platform, and Confluent should really be the first and foremost that comes to mind. So TJ had mentioned that we've actually built upon the Apache Kafka open source project, and we'll set that dark blue line as Apache Kafka is kind of like where we've taken Apache Kafka and improved it going higher, but also have added value below it as well. So some of the things that we've done, if I was a developer, I'd want to be able to have true multi-language development support in a platform like that. So we've got non-Java clients, we've got a REST proxy, and we've even got administrative REST APIs that you can use. And not only that, but we've got the power of the KSQL DB, the ability for you to be able to write transact SQL-like statements directly in a Kafka platform and manipulate, enrich, and work with that data set directly in cluster. So for excellent performance and excellent ease of use. Not only that, but ease of use, let's talk about being an operator. So we've built in metrics and a control center platform for you to be able to administer your clusters, view your clusters. We've got fantastic ways of automating the development and delivery through a DevOps fashion with Ansible playbooks. We've got a Kubernetes operator if you're deploying on AKS. And if I were an architect or an executive, I'd want to understand that, yes, this is a platform that has got true enterprise-grade security built into it. I can reduce any of the risk impact that I might have by having somebody else run the platform for me. And we're pushing a 99.95 SLA with resiliency. So we give you true freedom of choice around where I would want to deploy the platform, how I would want to run the platform, but we also support you in that journey and can help you get up to speed really quickly as well. So if we were to kind of look at a basic architecture of what it would be like to implement Confluent Cloud in a hybrid cloud architecture. So we've got our on-premise environment already with some open source Kafka and the Confluent platform running on some VMs inside of our environment. And we're ingesting data from all of these disparate data sources. And what we're going to talk about today is how we can kind of take on-prem data sources and unlock them to Confluent Cloud and then deliver enriched data from Confluent Cloud to Azure Cosmos DB. So if you see on the right, we're kind of showing how we've got Confluent Cloud running in Azure with KSQL DB, and we're actually going to press out some enriched data to Cosmos DB. We can also run on other cloud service providers, but I prefer Azure myself, and there's a reason. So data platform modernization. This is going to be around the premise of what we're going to show in the demo. This will be all about what we can do for being able to deliver a modern data platform and help you move data into the cloud faster and easier. So when we think of some of the challenges around migrating a database, first and foremost, it's cost. You're going to have data systems that might take years to migrate. And not only that, but now you're going to have double the expense. You're going to have your on-prem data services and your cloud data services. Not only that, but you're going to have that lag in time to analytics ready data. I mean, really, when we talk about migrating to the cloud, we've got batch processes running on premise that we then need to kind of figure out how to translate that to a cloud native pattern. And not only that, but really, you're going to be running in a way where you're not going to be truly hybrid or multi-cloud. You're still going to be on-prem and consuming the cloud. So let's show you what good looks like. Good looks like modernizing a true cloud native database architecture with an event streaming platform like Confluent. First and foremost, we can reduce your total cost of ownership by giving you the ability to process that data as it's moving in stream right at the Kafka cluster. Not only that, but we can help you really build out true real-time event streaming applications that can provide up to the second insight for you and your consumers. Your employees are going to love this as well, because first and foremost, it's going to consolidate down all of those disparate data silos into one unique view of your data across your enterprise through the Confluent Cloud Platform. So what we're going to do now is we're going to dive into a demo. We're going to take some data from an on-premise environment. We're going to merge it together into Confluent Cloud. We're going to do a little bit of data enrichment as well, and then we'll deliver it out to Azure Cosmos DB to show you what it's like to marry together the power of the Confluent Cloud Platform and Azure Cosmos DB.
Okay, so for this demo, we're going to be showing how we're going to take existing data from two disparate data sources, one of them user information stored in a database, and another one page view data that's consistently being gleaned from an e-commerce website. And what we've been asked to do is actually enrich these two data sets together inside of Confluent Cloud running on Microsoft Azure and produce some outputs using KSQL. So we've been asked specifically to take that page view data or clickstream data and merge it together with user data so that we can find specifically women that are viewing pages. Not only that, but kind of get an aggregate of page views by region, and then also find women in certain regions that are accomplished readers based upon the amount of page views they have. And we're going to do that all inside of KSQL DB on Confluent Cloud. And then I'm going to show you how we can take those resulting data sets and sync them out to Azure Cosmos DB, where the team that has made this request would actually like to run some further analytics on the data sets that we're providing to them. So let's begin. I've already logged us into Confluent Cloud, and here we can see the welcome screen. This is where we'll be able to choose which environment we'll be working with. So I've already got us an environment provisioned for this demo. And inside of here, you'll see that we've got a cluster up and running. It's already got some data that's flowing through it. And let's take a further look. So here's the initial overview into what's running in the cluster. We can kind of see some metrics here showing throughput and storage, but let me kind of walk you back through that use case again. So using stream lineage, part of Confluent Cloud, we can see that we've got a page view and a set of user data that we've turned into individual topics inside of the platform. And what we've done to kind of pre-prep this demo is we've created a SQL query in KSQL DB that is going to merge those together and give us all of the records that are page views by women and deliver them to a new topic. We've then also done a little bit more prep, and we've created page views by region. So this is all females that are viewing certain pages and by the region. We've also got another that is specifically aggregating out women that are in a specific region. And then we've got our accomplished female readers down here at the bottom. And what we're doing with each of these is we're taking this enriched data that we got from those two original sources, we're applying new queries, and we're delivering those to new topics on their own. So let's take a little bit deeper of a dive into what makes up a topic and show you some more. So here's a view into the topics that are running on the cluster. And we've got two types of topics. We've got raw topics and we've got curated topics. So the raw topics we'd be talking about would be page views, or the data that's coming from that original data connection that we've got. And users is another example of a raw topic. And then curated topics are topics that we've created through enrichment or through some other form of manipulation or discovery using either KSQL or Kafka streams. So we actually do have an accomplished female readers topic here. And we can see that there's actually data being produced from this topic. We can actually click into here and see the messages that are being created by this topic or into this topic. And we see messages are being produced. So our data sets are producing data. Our KSQL queries are actually enriching that data, and they're being delivered into a new topic. As part of the Confluent Cloud solution, we also have the schema registry. And this allows for us to validate that we're actually getting good data or quality data into the topic and into the cluster versus junk data. So this allows us to actually create a strict schema that any messages coming into the platform have to conform to. And a fantastic part about the schema registry is we can actually have backwards compatibility. So the schema can evolve for new applications while still being able to service older consumers of those topics. And basically this allows you to evolve your schema and evolve your applications in life cycles independent of one another. And a great piece too is we also have the ability to have versioning of those schemas as well. So we've talked a little bit about what the demo is going to comprise of, a couple of basic bits of functionality inside of Confluent Cloud. Now let's actually talk about how we're going to take that data that was created for the accomplished female readers and get it out to Azure Cosmos DB for our analytics team to actually start working with that data. So we'll come here to data integration for this cluster, and we can see that we've got producers and consumers. So producers are things that are creating data for the cluster to receive, and consumers are applications or processes that we've got that are going to be consuming data from the cluster. And what's interesting is with clients, those could be basically developed in any form of programming language that you'd like to use. So we've got supported connectors for Java and Python and Ruby and Spring Boot. But there's also ways that we could have connectors interacting with the cluster, where we could actually have source connectors and sink connectors. So a source connector would be, we would want to connect up to something like a database or like a data producer and flow that data into Confluent Cloud. And a sink connector is what we're going to use today to actually sync the data that we've created through that curated topic of accomplished female readers out to Cosmos DB. So let's add a new connector. And as you see here, we've got connectors for all different types of sources and sinks. These are supported by Confluent. And right here, we've got the Azure Cosmos DB sync connector, which we're going to use. It's a fully managed connector, meaning we just provide it some metadata in order for it to be stood up, and it will be provisioned into the cluster for us, and it will be ready to start pushing data into Cosmos DB. So what we're going to do is we're going to choose the topic that we would like to source the data from to sync it to Cosmos DB. So we have the topic accomplished female readers. We're going to choose an input message type. So these would be the format that the messages will be coming from the topic in. And we've got a schema registry based JSON input message type. And for the Kafka cluster credentials for this connector, we're going to use a service account, which I've already pre-provisioned and given the appropriate permissions to this cluster and the topics. And now we just need to provide a little bit more information we've gotten from Cosmos DB, specifically what's our endpoint that we'll be using. What's our connection key? And a great fact about the Cosmos connection keys is typically for databases, you'll be able to have a primary and a secondary key, so you could enforce key rotations at any point in time. Remember that if you've got an active connector, when you're rotating those keys, you can just come in here, replace the key, update the connector, and then rotate your keys in Cosmos as needed. So we're going to give it the database name inside of Cosmos, which is Reader Analytics. And then here we have what's known as a topic to container map. So basically what we're going to do is we're going to provide the topic name and map it to the container in Azure Cosmos DB that we want to deliver those messages to. So we will have the topic name of accomplished female readers, and we're going to be mapping it to the accomplished female readers container inside of Cosmos DB. So we need to choose an ID strategy so that we've got unique identifiers for all of the messages that are being sent over to Cosmos DB. Here we're going to choose a Kafka metadata strategy where we're going to use a combination of the topic name, the partition, and the offset to uniquely identify each of those keys or each of those values and messages. And here we will choose the number of tasks that we want to run for this connector. So let's go ahead and provision this connector. And before provisions, we should get a view of the JSON output that we would use to provision this connector if we were doing it via the CLI, which we'll do a demonstration of again in the near future. So let's go ahead and launch this. We know that we've got a cost estimate here of what it'll cost us to run this. So let's go ahead and run it and start sending some of that data over to Cosmos DB. So our connector has been sent in for provisioning. As we can see, we've got a provisioning status for this sync connector to Cosmos DB. And in a moment, we should have a Cosmos DB sync connector up and running, and we'll be able to start seeing the messages that are arriving into Cosmos DB. Okay, we've been notified that our sync connector is now up and running. So let's take a look at the connector. Now we've got messages that are already in that topic, so it's going to take a moment for the connector to catch up to those messages that have been out there already and start writing them into Cosmos DB. But once it does, we'll actually start seeing the messages being processed and synced via the connector. All right, so we've got messages flowing through the connector. Let's come over here to Cosmos DB and take a look inside of our Reader Analytics database at the accomplished female readers container. And here we have items that we can view and see if we're actually receiving messages in from Confluent Cloud, which we are. So we've got the IDs mapping to the ID inside of the container. And as we can see, we've got clickstream information being delivered, female looking at a certain page in a certain region. Again, different page, different region, different page. So the connector is working, and now we can notify the team that was asking to have this certain subset of data delivered to them in Cosmos DB from Confluent Cloud. I hope this demonstration was helpful and giving you an explanation of how we took source data, brought it into Confluent Cloud, created an enriched topic with KSQL DB, and then provided a sync for that topic out to Azure Cosmos DB.
Awesome. Jake, that was a fantastic demo. Clickstream data is everywhere. Being able to mirror it into your Cosmos DB environment for downstream analytics and merge it with that customer data is super impactful. So we want to give you all the tools you need to be successful and start trying this out at home today. So get started for free. We have a $400 free credit over a 2-month window. No credit card needed. So go to confluent.io/confluent-cloud or find us on Azure Marketplace. And we have a fantastic developer site as well at developer.confluent.io, where you can learn all things Kafka, all things Confluent, and get started with some really, really cool tutorials. So with that, we'll wrap up and want to say thank you for your time and attention.
Thank you, everybody.